Okay, we're going to have a little video here on confidence intervals. Okay, so what is a confidence interval? Well, first of all, let's go over here first. So, a confidence interval, think about it like this. Let's say I've had a test. Over the past 10 years, I've had a test. Okay, 10 years I've had a test. And on this test, the average class, the mean, oh my God, my writing's horrible. The mean of the test is 85. Well, let's say standard deviation is equal to 3, right? So if I got 10 years of this test having this, and it produces mean and standard deviation. And generally it's going to have a normal distribution, okay, with 85 in the middle. So I can use a confidence interval. I think confidence intervals off the top of my head, 90, 95%, and 90. So 90% confidence, 95% confidence, and 99% confidence. And if I use 95% confidence, for example, I'm just going to make up these numbers. And let's say for 95% confidence, it was plus 4 and minus 4. That would mean, in terms here, I'd add 4 to here, 89 and 81. That'd mean the next time I give that test, the mean is going to fall somewhere between these two. Okay? The mean is going to fall somewhere between 81 and 89. 95% of the time, it's going to land between those two. Now, there is a 5% chance I either have a higher or lower as we go. But that's what it means. So if for the next couple times, let's say I run it here, and the confidence is 82, and then I go over here, and the confidence is, sorry, not the confidence, the mean on this one, it ends up being 87. I'm still always between here. And there's a good little example here. So let's use this as an example. This is my 85% 85% mean. Okay? And now, if I drew a line here through these two, that'd be my 95% confidence here. Okay? And what would we say? 89 and 81. 95% of the time, let's say this is the next 20 times I give this test, 1 right here is going to be outside the range of 81 to 89. But 95% of the time, statistically, they're going to be in there. Right? So that's kind of just a general idea of you're using past facts to kind of project into the future. So where we see this a lot is in political polling. So if you go back to, I think this 2016 election, there's polling here, okay, for Donald Trump and Hillary Clinton. Okay, so they poll and say, who are you going to vote for, Donald Trump, Hillary Clinton? So if we look at Donald here, 43% of people said they're going to vote. But within that, there's a range of error, okay, plus or minus. So that means, knowing it's 43%, it could be as high as 46 or as low as 40. So there was a plus 3 and minus 3 there. Okay? And then for Hillary, we had 42. She could go up to 45 and could go all the way down to 39. So you can see here, like the polls kind of show a story, but they have to predict plus or minus their error. So they could be 3% up or 3% down in that case. And you'll see this a lot of time, like the more people you poll, the higher the confidence, the smaller the like percentage point error or that confidence level will be. So if we look here, the total sample, this is another sample here for voting. I forget what exactly it's voting for. but the total sample was 2,200 people. And their plus or minus here was 2.4%. Okay, so the confidence interval is 2.4%. So let's say we were back there with Hillary with 43. That means she could go up to 45.4 or go down to, what's that, 40.6. Okay, and if you look here, generally, where we have the higher number is where we have the lowest interval. But if you look at the low numbers, so there's a couple high numbers here, right? Over 1,000, we're around 3. There's 1,000, we're around 3, 3%. Okay? But then, if you look here, we have very low numbers of people, right? For this population here, it's a 9% percentage difference. So that 43 could go all the way down to 34 or all the way up to 52 because we just don't have enough data on those people. We haven't surveyed enough in order to get a representation of it. Here's another one here for, this would be a Canadian election, where we have 36% are here, but it could go up or down. It could go down to 31. It could go up to 42. And see, generally we have the same thing on the other side. So keep that in mind when you look at polls, or if you look at any projection, along the bottom, it will say the confidence level, 90%, 95 is usually what they play with. Or they'll have a plus minus 5%. Okay, that's what it looks like here. Oh, this looks like 6% here. Okay, so my last one. And you can see here, generally with more, this is for 95%, the more people we survey here, the sample size as it grows, in this case, this is not 3,000 is always going to give you this number. It depends on the population size. But when you only go about 100 people, you're looking at 10% plus or minus. But as we keep going, 1,000, we're at 3%. We're at 3% here. We get up to 2,000. We're like 2.2%, and it keeps going here. 3,000 would be about 1.8 or 1.9% plus or minus. So if we started with that 45 as our guideline, at the very first, we have a wide range of 35 to 55. When we get down to 3,000 people, that 45 becomes essentially, I'm going to round the 2, 47 to 43. Okay? So that's what we're working with. So I'll go back up here. Here's our formula here. Okay. There's the formula, so write it down. Do some magic here. Now there are two different confident intervals formulas. Okay. And I'm going to teach you one. I'm going to show you the other, but I'm going to test you on the other one. Okay. So this one here is for when you have a population. Just like I had said earlier with my test, I had 20 tests. I was basing off the 20 tests I previously run. So this is when you have like a full population for the sample you want. Okay. Now, if we look here, confident interval, it's a plus minus. So when you find this number, we're going to split it into a plus section and a minus section. Just as I did with that 45, let's say the percentage was 5%. I added 5 to it to get the 50. I've subtracted 5 to it to get the 40. We're going to do the same thing here. Okay. Now we know what mean is with the x with the line over it. We know what this symbol means, that standard deviation, and n is number. This z here is not z-score. What is a critical value? If we go down to this chart, I'm going to ignore this part. Ignore that. Okay. So if you're looking to get 90 percentile, 90% confidence, your Z number that you're going to put in there is this number here, 1.645. Looking for 95, the Z number is 1.9. 99th percentile is 2.576. So that's what those numbers there are for you to use in your formula. So I would write those down somewhere. If you want to pause your video here and write that down. I'll stop petting my dog and away we go. Okay, here we go. So we have a paint manufacturer. Okay. So paint manufacturer, it's important for a paint manufacturer to have a quick drying paint so the people putting on paint for a living can reapply it as soon as they can, saves them time. So from experience, from the testing, latex paints have a standard deviation of 10.5 minutes. Okay. The manufacturer wants to advertise and say our paint dries in so many minutes. So 20 test areas of equal size were painted. Okay. They found the mean drying time was 75.4 minutes. What we're looking for is the 95% confidence for that interval. So they want to advertise, say 95% of the time our paint dries in between these number of minutes. So if we pull the information out here, the mean of this is 75.4. Standard deviation was 10.5. And the number of samples was 20. And then our Z number, we want 95th percentile. So 95th percentile is 1.960. Okay. Now we just take that in and we run the numbers. So 75.4 plus or minus 1.96 bracket 10.5 divided by the square root of 20. So I'm going to get this number here. Where's my calculator? So I have 10.5 divided by the square root of 20 equals this, and I'm going to times it by 1.96. And that equals 4.6. So it's going to be plus or minus 4.6. So therefore, I'm going to do this over here. I'm going to go 75.4 plus 4.6. So what's that? That's 80, I believe. And then 75.4 minus 4.6. Minus 4. I want to say it's 70.8. Should I double check my math? 75.4 minus 4.6. 70.8. So therefore, the drying time, 95% of the time, is going to be between 70.8 and 80 minutes. So 95% of the time, that's how long it'll take to dry the paint. All right. So I'm going to set up the next one for you. And then you guys can pause the video and finish it and see if you get the same answer I do. I'm going to summarize this big long question. There's a lot of words in it. So Julie enjoys running. Okay, every day she records her time. She records her time 90 times. And within that 90 times, she finds her standard deviation is 1.8 minutes. Her average run time is 15.6. She's trying to figure out with 95% confidence what's going to be her run time the next time out. So when she goes for a 2-mile run, 95% of the time she's going to be between these two numbers. So try to fill these in. You always pause the video to fill it in and see if you have it right. So I only have 30 minutes to make a video, so I can't pause literally or run over my time. So our mean time is 15.6. The number of times she does is 90, 1.8. The Z for 95% is 1.96. And away we go. We plug all those numbers in. So it's going to be the mean, 15.6, plus or minus. Oops, over my bed. Z is 6 bracket 1.8 divided by the square root of 90. My fancy calculator, 1.8 divided by the square root of 90 equals that, times it by 1.96, 0.37. Plus or minus 0.37. So I'm going to split it up, do my plus, do my minus, so 15.6 plus 0.37, which is going to be 15.97, and 15.6 minus 0.37, I want to say that's going to be 15.23. So her next run is going to finish. So we have 95% confidence. Her run is going to be between 15.23 and 15.97 minutes. All right. Do one more, then I'll show you the other video, the other way, the other formula for this. So my basketball team, over the last 20 games, has scored an average of 65 points with a standard deviation of 5 points. Okay. What range of, that should say scores, do you believe with 99% confidence, do you believe they will score in the next game? So we're looking for 99% confidence this time. So I'll let you fill in your numbers. We'll work from there. So it's an average of 65. The mean's 5. We have 20 games, and this number is going to be 2.576. So then means, now always just pause the video, see if you can do it right, and then figure out where your errors are if you did any. Hopefully I don't make any. That is bound to happen. So that is going to equal 5 divided by the square root of 20 times 2.576, 2.88. 65 plus or minus 2.88. So that our plus, I'm going to go 65 plus 2.88 and 65 minus 2.88. So this is going to be 67.88. And this is going to be minus 3 is 62. Add 12 to it. There we go. So there's my scoring range with 99% confidence. I'll be between these two numbers next time. All right. Hopefully that makes sense. Your questions for homework, there's 3 questions for practice, and they're all dealing with this formula here. Okay. I'm going to show you this formula as an FYI, because you'll be like, hey, how did they do the political ones? like the Donald Trump, Hillary Clinton. There's no way they polled everybody. So the question is, how did they do that? Oops. So how did they do that? And what they do is proportional with this one. Okay. So the way this works, we have a little bit different formula where P, oops, I don't know the name for this hat, but I'm just going to call it the hat. Probably a mathematical term for it. That's the sample proportion. Okay. So you got to figure out your sample proportion, such as like if I survey 20 out of 100 students, my sample proportion would be 0.2, right? So 20 divided by 100, 0.2. Okay, so this kind of gives you where we had that chart earlier, where the higher proportion of the people we sample, the lower the margin of error gets, because we're sampling more compared to if we only sampled a little bit. Right? So, an n is our sample size, and then we go from there. Critical number still counts. So voter turnout in a municipal election is often very low. In a recent election, the mayor got 53% of the vote of the voters. Okay? But only 1,500 voters turned out. Okay? Constructed 90% confidence for the interval proportion of those who supported the mayor. So our formula is, so our confidence interval equals P plus or minus our Z, bracket the square root of 1 minus P, all divided by the square root of n. All right, so let's figure out our numbers here. This is going to be 53%, which equals 0.53. Right? Our Z, we're looking at 90%, correct? So that equals 1.645. Now, I kind of like to do 1 minus this beforehand. If that's 53, that's going to be 0.47. Okay? So then we just plug it all in again. So 0.53 plus or minus 1.645 bracket the square root of, oops, I forgot this, 0.53, and, oh, I'm all over the place here. This goes in here. 0.53 times 0.43. That's because I just figured that out earlier. And I wrote it down wrong, 0.47 divided by the square root of 20. Boom. So then we just run the math of that. So I'm going to go square root of bracket 0.53 times 0.4347. Oops. Let's do this. 0.53 times 0.47 plus equals square root equals, so that's the top, divided by the square root of 20, which equals that, and I'm going to times that by 1.645. So we get plus or minus, oops, I lost my number, 0.18. 0.18. So therefore I have to do it twice. 0.53 plus 0.18 and 0.53 minus 0.18. So that's going to be 0.71, I believe. Add 20 minus 2. And this is going to be 0.35. What did I do wrong here? I got the totally different number from what they got here. Oh, geez. my N. My N was 1500, not 20. All right. One of you should have said that, so I didn't look like a fool now, but that's fine. I had the answer key in front of me. It seemed like a big, wide margin to swing 20% in the pool. Okay, then we can go backwards here. Okay, there's our first answer. Then I'm going to divide this by the square root of 1500, which equals that. Then times that by 1.645. There we go. Plus or minus 0.02. I was going to go 2 dozen places. 0.02. 0.02. 0 minus 0.02. Oops. There goes 0.55 and 0.51. Okay. So that means if you'd have 90% confidence, 90% confidence is everyone showed up. The mayor would have got between 51 and 55% of the total votes. Okay. So there is confidence intervals. Hopefully, I don't know if you enjoyed it, but hopefully you understand it, and we'll go from there.